All right, we are still in R2, but we're doing a little different section, okay, something we haven't done yet, and that is about exponents, as you see the title of it right here. Let's talk about what an exponent is. You've probably seen this a bunch. You've probably seen x and then a little tiny 2 at the top. What do we say, girls? What do we say right here? X squared, right? Or what's another way you could say this? There's another way you could say this. Okay, you could say x to the power 2, or x to the second power, or x squared. There's a bunch of ways you could say that. What does that mean when I have an x and a little tiny 2 up there? Does that mean 2 times x? No, it means what? X, what? Times x. Very good. What does 2x mean? Okay, 2 times x, or it's really x plus x, isn't it? When you agree? What if this was 3x? Then what would this be? X plus what? X. Everybody see that? All right. But x squared would be x times x. What if you had a little 3 right there instead of a 2? What do we call that? X cubed, which means x times x times x, 3 times, all right? So that's what that means. You've seen this before, right? Sure, you've done that plenty of times. Let's talk about, let's go do this. We'll go x to the a. A means it could be any number, okay? The x, that big number on the bottom, and it doesn't always have to be x. It could be an a, it could be a b or a c or whatever. It could be a number, all right? But that big number down the bottom, that's called the base, all right? And this little number on top, that's the actual exponent. So if you had something like this, you can't say x squared with this, but you would say what? X to the, let's put it in parentheses, x to the what? A power. You could say the power of a if you wanted to, but most people say to the a power. Or some people put a little th on there, but that'd be kind of dumb, wouldn't it? The eighth, a-t-h, yeah, that'd be dumb. So let's just say x to the a power. Everybody got it? So that means x is your base, this is your exponent, and we go from there. Let's put some regular numbers on there. So what if I had 3 to the 4th power? Now, we don't have a special name. When we have x to the 2nd power, we could say just x what? Squared. So that's a little easier, quicker way of saying it. Instead of saying x to the 2nd, you could say x to the 2nd, that's perfectly fine. But x squared is what most people would say here. So if you had x to the 3rd power, what do you say here? We already said it earlier. It's just x cubed. And that's really the end of the special names for the exponents, okay? You just have x squared, x cubed, and that's it. After that, if you had x to the 4th power, you would just say x to the 4th power. Sometimes we get a little lazy, we just say x to the 4th. It's fine. I'm okay with that. Everybody with me on that? On how to say these things and what they mean? All right. So what about this thing? 3 to the 4th power. First of all, let's write it down, what it means. 3 is your base, so you're going to multiply 3 by itself how many times? 4 times. So I'm going to go 3 times 3 times 3 times 3. That's what that means right there. So 3 to the 4th power means you take your base and you multiply it by itself that many times, 4 times. It's not 3 plus 3 plus 3 plus 3. Okay, it's times. 3 times 3 times 3 times 3. We good? And then we figure this out, okay? You could kind of do this in your head, couldn't you? What's 3 times 3? 9. And then you got another 3 times 3. What's that? 9. 9 times 9 is 81. So 3 to the 4th is the same thing as 81. All right? Starting off really easy. Just going right back to the beginning. The beginning of doing exponents. I'm sure you were taught that in Algebra 1, but we're going to teach it again. So here's a couple examples. I don't think this is like an official example, but we'll just do a couple quick little refresher examples. What if I did something like this? Remember the PEMDAS thing? You do, there's your exponents. We haven't done that yet, have we? We've done parentheses before we did addition and subtraction, correct? And before we did multiplication. But we haven't done exponents yet, so now's the first time we're going to do that. So we do exponents before you do any multiplication and division and before you do any addition and subtraction. So right here, what's going on right here? I got 4 times 3 squared. So what am I going to do first? Am I going to go 4 times 3? Am I going to go in order from left to right? No. What do I have to do first? I got to do the exponent first. So I got to do the 3 squared first. Super important that you use your order of operations. Everybody see that? All right, so let's do it. I'll tell you what, I'm going to work up and down on this. So I haven't multiplied anything by the 4 yet, so I'll put the 4 there. So I'm multiplying it by this, 3 squared. Can you do 3 squared in your head? Yeah. What is it? It's 3 times 3. What is 3 times 3? It's 9. So 3 squared is 9. 4 times 9 is 36. And there's your answer. Pretty easy, isn't it? Yeah. Just got to know the order that you do things. Let's do another pre-example. It's really not an official example, but let's just get us started here. All right, here we go. Now we have addition, don't we? But what do you always do first in this situation? You always do the what first? The exponents first. Let's do the exponents. I'm not even thinking about addition just yet. In the next step I will, but right now I'm just thinking about the exponents. So I got to figure out what that is, and then I got to figure out what that is. Well, what is 2 squared? Well, what does that mean? It means 2 what? Times 2. 2 times 2 is 4. Plus 3 squared. Done that a couple times. What is 3 squared? It's 9. And now you work it out. 4 plus 9 is 13, and there you go. See how I showed my steps? Wasn't much to show, right? But I did. I put a 4 down here and a 9 right there. That's showing my work, showing my steps. I think it's important to do that. All right, let's do another one. That's a little trickier. I'm going to work across on this one. Now check this out. Look at that minus sign. That's a negative, isn't it? It's a negative. But it's not really a negative 2. Everybody see that? So I'm not taking negative 2 to the 4th. What am I taking to the 4th power here? Just the what? Just the 2. And then I just put a negative out in front. I'm going to show you another one in a second. All right? So this one, it's not in parentheses. Okay? I'm not taking both of these things to the 4th. I'm only taking the 2 to the 4th. So what do I do with that? I don't just throw it away. I just leave it out front. Everybody got it? Because the next one we're going to do, it's a little bit different. So now, what is 2 to the 4th? Well, if you don't know what it is off the top of your head, it's fine. Write it down. Brianna, you writing this down? 2 times 2 times 2 times 2. Right? That's 2 to the 4th. And let's do this in our head. 2 times 2 right there is what? 4. This 2 times 2 is 4. It's being multiplied. You got a negative out in front. So what's my answer now? Negative 16. Now that's different than this. Do you see the difference? What's the difference between this first problem we did and this one right here? So, come on, it's obvious. Tell me. You got a parentheses, right? You got a parentheses right here. Now that's really important because this one says you're taking negative 2 and you're taking negative 2 to the 4th power. You weren't really taking negative 2 to the 4th power here, were you? Okay, you were only taking 2 to the 4th power, and then you just stuck that negative out in front. But this one, this is where a lot of students mess up. All right, so don't you be that one that messes this up. Make sure you get this straight. So you're taking the negative 2 to the 4th power. So here's what it is. You don't just stick the negative out in front this time. Because it's in parentheses, you're taking everything in that parentheses to the 4th power. So I've got negative 2 times negative 2 times negative 2 times another negative 2. 4 times, right? Is it going to change our answer? It may not. I don't know. Let's see if it does. Let's break them up again. Again, we may not be able to do all that in your head. I don't know. Maybe you can. But I'm going to break them up like this. What's negative 2 times negative 2? What's a negative times a negative? It's positive. So that's positive what? 4. And then I do the same thing here. We just did it, right? Negative 2 times negative 2 is another positive 4. 4 times 4, positive 4 times positive 4 is positive 16. Is that a different answer than this? Absolutely. All right? I've had kids all the time, students all the time. They might miss a negative, and they're like, Mr. Hammer, come on. It's the same thing, just missing the negative sign. Well, it's not the same thing then. It's completely different. Would you understand that? So here's the difference. Positive 16, Tristan, would mean you are giving me $16. That's positive for me, okay? But it's what for you? It's negative for you. You everybody follow me on that? So it's not the same, is it? He feels a lot worse. I feel a lot better because he lost $16 and I gained $16, okay? So there's a big difference. It's a huge difference between negative and positive, all right? They're on completely different ends of the number line, all right? They are different numbers. That's super important. That one right there is probably the trickiest out of the ones we're going to do. Let's do another one and we'll go to something. Then we'll do some more stuff with this. What if you had this? Here we go. You writing this down? It's the best way to stay awake in here. Follow along, keep your eyes open, and write stuff down. Another way to stay awake is maybe try to do this in your head before I actually do it. Remember order of operations. Do we do exponents first, then multiplication, then addition and subtraction? So the first thing we do is this right here. Why do we do that first? Because it's got a what to it? It's an exponent, right? So I'm just going to write it down. You might be able to do some of this in your head, all right? But I'm going to write down every step just so you see. So there's the 5 times what? 3 squared. We've done that about 3 or 4 times already today. What's 3 squared? It's 9. And then plus, and if you wanted to, now that we've done the exponent, let's go ahead and do this multiplication. What's 2 times 4? It's 8. I'll answer since nobody's talking to me today. You follow my steps? I did the exponent first, then I did this multiplication. Now I can go ahead and do this. Do I go 5 times 9 or do I go 9 plus 8? What do I do first? 5 times 9. Okay, I do that because order of operations. You do multiplication before you do addition. What's 5 times 9? 45. And then plus 8, and that would be 53. And there you go. That's how you do stuff like that. It's not that difficult, is it? No. But this is the first thing that we're doing, okay? So you know what's going to happen after this easy stuff. Does it get easier? No, it usually gets what? It usually gets harder. You're a tough crowd. Man, it's hard getting stuff out of you guys. Goodness gracious. All right, I'll just teach. Here we go. Yeah, I can skip that. Let's go to this. All right, I got a definition. All right. So somebody came up with this. They said it was true, so we just accept it as truth. Here's my base, right? Now check this exponent out. It says 0. X to the 0. What does that mean? Does that mean I multiply it 0 times so it's just an x? I don't know. Well, I don't know who came up with this, but somebody came up with this definition, and they defined x to the 0 to be equal to 1. It's not 1x. It's just the number 1. Everybody hear me on that? That's super important. A lot of people look like this and say, oh, that's 1x. It's not 1x. It's what? What's anything? That's what x represents, doesn't it? Any number to the 0 power is equal to what? It's just equal to the number 1. For instance, what if I put an actual number here instead of a variable? What if I put 3 to the 0? What is 3 to the 0? It's 1. Anything to the 0 power is 1. All right? If I put 257 to the 0 power, what's that equal to? It's 1. It's just a definition. Somebody came up with it. They decided that that was true. And here we go. Let's see. What else do I want to say? Let's do another variation of this. What if I did this? What if I said -3 to the 0? What is it? Say it. Is it 1? Which one? Which one is it? Is it -1 or 1? It's one of them, I promise. Why is it -1, Tristan? That's right. Because what's being taken to the 0 power? Is the negative being taken to the 0 power? No, just the what? Just the 3. All right, so what do I do with that negative? Just like we did earlier. I just leave it out front, and now I can go 3 to the 0 is what? A 1, so that is -1. What if I did this? Now, what's being taken to the 0 power? Is it just the 3 this time? Nope. Everything inside that parentheses is being taken to the 0 power. So it's -3 to the 0. So everything in here is being taken to the 0. So what's my answer now? No. Everything in here is being taken to the 0. All right? So it doesn't matter what's inside that parentheses. I could have 15 different things inside that parentheses. If it's all in parentheses and being taken to the 0 power, what's my answer? It's just 1. Okay? For instance, watch this. This is going to look crazy and confusing, but it's an easy answer. Everybody looking? I'm just making this up. I didn't even expect to do this, but there you go. What's your answer? Without doing any math at all, hardly even thinking about it. What's your answer? It's a 1. That's right. It doesn't matter. Remember I said it doesn't matter if you got 15 things inside that parentheses. Doesn't matter what's inside the parentheses. Anything to the 0 power is what? It's 1. It's the number 1. We good? All right. So that was kind of easy. Now we're going to do the part the students usually get a little mixed up with. All right. You might have done this before and weren't able to figure it out. Convince yourself right now that this is the time that you're going to learn this, okay? So watch what we do here. What if I have, yeah, I'll do it like they do it. What about this? This looks different than what we've done before. This isn't just a negative out in front like we did with that -3 squared. What's negative here? Not just the n, but what? In general. The exponent is negative, okay? So watch. When you deal with negative exponents, there's a little trick. There's a little rule that we use. Negative exponents. I'll just shorten it. There's a little trick that we use. It's not really a trick. It's just how you do it. So watch this. We don't like negative exponents, okay? Math people in general. They don't want to use that negative exponent. Sometimes you do get stuff that comes out with a negative exponent. But what we want to do is we want to change this from a negative exponent to a what? To a positive exponent. Here's how you do it. Everybody watching? Now, technically that's over 1. You could write any number over 1, couldn't you? And you could also do what else? You can multiply every number by 1. Brianna, you watching? Think you're dozing off. Come on. I need you focused. So check this out. Everybody watch. It's not that bad. Am I really that boring? Is it that boring? You don't know what boring is then. Because I've had professors in college that were dead boring.
Hi, can you send down Amir, my resources, down the guidance, please?
All right. Man, I've had teachers that get up there and they say, I mean, they just like read from the book or they just speak all monotone. You don't think I'm speaking monotone, do you? Don't you think I got a little energy to me? Yeah, you should appreciate that. You really should, okay? Because not every teacher's like that. I've had tons of teachers that were just like, and you know, 3 to the second is 3 times 3 is 9. Okay, next to we'll go to the next problem. You know, I've had teachers like that. I don't feel like I'm like that, do you? I feel like I got a little bit of little energy to me, right? Don't you think? All right, anyway. So stay awake, pay attention, come on. You got to do your part, I'm trying to do my part. So watch what we do. When you have a negative exponent, we are going to take that base and that negative exponent, and what we're going to do is we're going to flip it to the bottom. Now, sometimes the negative exponent's on the bottom, so where are you going to flip it? To the top, exactly. So we'll just say we flip it, all right, depending on where it is. Now, once we flip it to the bottom, it leaves the top, and what we're going to do is we're going to change the negative exponent to a positive exponent. Everybody hear that? So if you have a negative exponent, how do you get rid of the negative exponent? Flip it and then change the exponent. All right, change it from negative to positive. It's not that hard, is it? All right, so if I want a positive exponent and I got a negative one, I flip it to the bottom. What if it was already on the bottom? We'll do an example like that. What if it was already on the bottom? Then I flip it where? To the top, and I change it from a negative to a positive exponent. So what do I write here? See, I flipped it to the bottom. This is 1 times a to the n, so this is just a to the n. What's left on top here? Not just nothing, but what? That 1 is, so I put 1. So that is how you do negative exponents. You flip it, and you change the sign of the exponent. Everybody hear me? All right, you flip it, and you change the sign of the exponent. So, for instance, what if I had this? We've been using this a lot today. We'll use it like this. This is a lot different than just negative 3 squared. Do you see the difference? This one, the exponent is negative, and this one, the exponent is just out in front. This just is what? We've already done this once. What's this one? No, it's negative 9. This is not negative 9. Everybody see that? It's a negative exponent. So what are we going to do? Remember, this is always written over 1, isn't it? So what am I going to do to make that a positive exponent? Flip it. That's right. So it's on the top. So where do I flip it to? The bottom. So let's see what I get. What's left on top now? A 1. There's a 1 left on top. If I flip it to the bottom, what happens to it? It becomes now what? 3 to the positive second power. And now we can figure this thing out. Again, what's left on top? A 1. What about the bottom? 3 squared, 9. There you go. So 3 to the negative second is the same as 1 over 9. Do you see that negative exponent doesn't really make your problem a negative answer or a positive answer? You got it? This negative out front makes that a negative answer. Okay, this negative exponent, what does it do? It flips it. Okay, if it was on the bottom, it would flip it to the top. If it was on the top, it flips it to the bottom. All right, I keep on saying, what if it was on the bottom? Let's do one where you got one of these on the bottom. So let's use the same number. So what if I had 1 over 3 to the negative second? Well, what don't you like about this? Why is that thing not simplified?
I don't like that it's a negative exponent.
I don't either. I agree with you. I don't like that it's a negative exponent either. So what are we going to do to it? We're going to take that whole thing and we're going to flip it. This time we flip it where? To the top. Why? Because it was on the bottom. You got it? So you flip it to the top. Now, when you get rid of it from the bottom, there's really nothing left. Technically, there's a 1, but you don't really even need the 1. So watch, we flip it to the top, and that becomes 3 to the what? Positive second. Yeah, there was a 1 on the bottom. Remember this? You always start with a 1 on top, 1 on the bottom. But I don't even need the 1 now. So now I can figure this out. Now it's just plain old what? 3 squared, which is 9. For the 5th or 6th time today, we've done 3 squared. So you should have that down pat now, right? 3 squared? Yeah. And there you go. So what does that mean? That means 1 over 3 to the negative second is the same thing as 9. Looks kind of weird because you see those negatives. I'm sorry, it's 3 to the negative second is positive 9. All right, let's do some examples. I mean, we've already done a few examples. Let's do some more. And we'll probably end with this. So this is example 8 in the book, if you want to look in the book. And a couple of these you'll see look just like what we've been doing. And it says it gives you this long thing to do. It says evaluate expressions containing negative exponents. What they want you to do is, if it's got a negative exponent, they don't want a negative exponent, all right? They want you to change all the negative exponents to positive exponents. You got it? So you're just going to be flipping, right? That's what we're going to be doing. So here we go. We got 2 to the negative third. I'll give you 20 seconds. Go. Figure out what it is. Write it down. You should be taking notes. Why aren't you taking notes? You should be taking notes. Write it down. See if you can get the right answer. You got 10 seconds left. Come on, write it down. So remember, this was over 1, wasn't it? And you always had a 1 out in front, if you forget. So this is a negative exponent, so what are we going to do with it? We're going to take that whole thing, we're going to flip it to the bottom. What's left on top then? This goes away, so what's left on top? A 1. Technically, a 1. All right, I want you to write it down, okay? That's great, but I want you to write it down. So you flip it, and then it was negative on top, now it's going to be a positive exponent on the bottom. And then you just work this thing out. 2 cubed, I think we did this already. Nah, did we do it? 2 times 2 times 2, what's that?
8.
It's 8. So there's your answer, 1 over 8. Okay, it's not 2 times 3. It is not 2 times 3. It's 2 to the third power. 2 times 2 times 2. You got to get that straight. Let's do another one. This is just as easy. You write this down and do it real quick. After a while, you don't have to do all those 1 things that we did. All right. So look, put a 1 here, put a 1 here. We're just doing that to get you started on this. Everybody get this? All right. So what is this? 1 over x to the 4th. Make sure you're getting this. All right. Let's do another one. This one's a little trickier. Oh my gosh. You kidding me?
Who was that?
All right, check this out. This is a little different. This is a little different. When you have a fraction, we haven't talked about that yet. So let's pay attention. Let's watch. You may think you got this stuff down. You're like, oh, God, this is so easy. Why am I even sitting here? This is going to be different. I can guarantee that people are going to struggle with this if you're not paying attention to me right this second. So when you have a fraction in a parentheses taken to a negative exponent, here's what we do. We still flip it, but don't flip it to the denominator. You could, it'll make it too confusing. Let me show you a little way of doing this. So what we're going to do is we're going to flip this fraction right now. So if I flip that fraction, what do I get? Just a 5 over 1, or just a 5. Now if I flip this, what do I do with this? Yeah, just make it a positive instead of a negative. See what I did? So I took that fraction, I flipped it, and I changed the sign of the exponent. So really, 1/5 to the negative second is the same as 5 to the second, which is what? 25. 5 times 5. Let's do one more and we'll quit. What about this one? No, actually, that was it. Yep, that was it. We'll stop. Okay, we'll stop, and we will continue tomorrow. And I will give homework tomorrow. Okay, no homework tonight, but I will give you homework on this thing tomorrow.